Welcome back to classification of equations. We're continuing in chapter 3 of the textbook. We're going to be picking up where we left off, section 3.5. So we were just talking about classifying equations as either differential or algebraic. And we're going to pick up a few more methods of categorizing or classifying these equations. And once we understand these classifications, we can have different methods of being able to solve these equations. So under the umbrella of differential equations, we can classify the order. So we can have, we'll be dealing a lot with first order and second order differential equations, and this does go up. You can have third order, fourth order, etc. Uh, differential equations. And so the order of a differential equation, we'll come down here a little bit. The order, so the number of the order is the order of the highest derivative in the function. So for example, if we have a sine of t, oops, multiplied by dx dt cubed plus tangent of x, and that equals 0. The highest order derivative here is this first order derivative. And we also have just an x. It's I should say, the highest order of the derivatives of the dependent variables. So we have the dependent variable x, which I've just pointed out, and that's a 0th order derivative. It's not a derivative, so we call it a 0th order. Um, just to point out, this 3 is the derivative cubed. It's not a third derivative. So that's a first. So this is a first order differential equation. For example, the next example, we have d2x. So this is the second derivative of x with respect to t plus dx dt. Again, this is a first derivative cubed plus tangent of x. So we've just added on a second order derivative equals 0. So this is a second order. This highest order, the order of the highest derivative is second order. And so this is a second order differential equation, ODE. We can continue if we have if we have the third derivative plus dy dt plus y equals 0. You have a third order differential equation, so this is a third order ODE. Sometimes, if for example this y didn't exist, you want to be careful categorizing these equations, because if you can rewrite, if there's no 0th order, same if there's no 0 first, second, if you only have higher order derivatives, that can be rewritten as a lower order problem. So if we substitute v equals dy dt into this previous example here, we would have the second derivative of v plus v equals 0, and that's a second order. That's the same equation, right? There's nothing, no new information or no changed information here, but this is a second order ODE. Um, and so it's the order is the highest order relative often to the lowest order. Usually, in most cases, you have a zeroth order and you don't need to make that substitution. Okay. Um, Next, also under differential equations, we have constant or variable coefficients. This is another way to classify this. So something is a constant coefficient, ordinary differential equation, if all the coefficients on your dependent variables are constant. Um, Keep writing here, are constant. So for example, our canonical equation for this course is going to look like mx double dot plus bx dot plus kx, say it equals 0. If your mass, your damping, and your spring stiffness are all constant values, say it's 5x double dot plus 2x dot plus 3x equals 0. If these values are constants, like they are here, then this is a constant coefficient, ODE. On the other hand, if you have a variable coefficient, you have a variable coefficient if your variables on your dependent, if the coefficients on dependent variables are variable with respect to your independent variable. If they change with respect to WRT with respect to the independent variable. So, for example, if you see something like sine of t x dot times x dot plus t squared x equals 0, I'll go ahead and I'll use blue here. So um, my dependent variables are x dot and x, and the coefficients, I'll use green, the coefficient on x is t squared, and the coefficient on x dot is sine of t. And so these coefficients vary with time. They change with our independent variable. I should add in variable if any coefficients are variable. So this is a variable coefficient. ODE. Um, and I'll throw in as well, the book has a periodic coefficient. And that is if any coefficient is either periodic with respect to time, so a trigonometric function like sine of t, like we have here, cosine, um, etc., or constant. So if you have something like sine of t times x dot plus 5x equals 0, this is a special case of variable coefficient where you're only dealing with periodic functions. Okay, we will go ahead and take a break, and in the next video we will cover the remaining sections.